Now, today we are dealing with the question of set line, and I've selected one of the questions that was in 2018, paper 1 and 18. It says that two vertices of a triangle ABC are A 3, 6, then B 7, 12. Find the equation of line AB. Then that was 3 marks. Then B, find the equation of the perpendicular bisector of AB. That was 4 marks. Then given that line AC is perpendicular to AB and the equation of line BC is y is equal to negative 5x plus 47. Find the coordinate of C. That is 3 marks. Now, you know that a triangle, let me just deal with the two vertices. First, I have a table that is line A, B. I'm dealing with the two lines. Then there is, because I'm given another one, B to C at that point. A, B, then B to C. A, B, then B to C. Then I'm given that point A is 3, 6. Then point B is 7, 12. Now, the first thing we need to find the equation of line AB, this line AB, and you know that first we need to find the gradient. Find the equation, we find the gradient, and the gradient is equal to change in y over change in x. Now, change in y over change in x, I find that change in y is the final y at point B is the final y, that is 12, then the initial y is 6. Now we find that 12 minus 6 over change in x is 7 minus 3. That is 7 minus 3. Now, what do I get there? That is 12 minus 6. I think that is 6. Then 7 minus 3 is what? 4. Now, the gradient at that point is 3 over 2. When simplified, I find the gradient of that line is 3 over 2. Then, to find the equation, I use the gradient, one of the point, and an arbitrary point. An arbitrary point, x what? X1. Now, one of the point, you take the initial point. This is the initial point AB. An arbitrary point which I have chosen to be xy. Any point on the line chosen to be xy. Then you use the gradient found. Now, it's like we want to find a new gradient. You want to find a new gradient using the arbitrary point. We're using the point A and the gradient found. Now, we will work this way. We find this one, the final. Now this means that is the final point. This is the initial point. We say that the final point was y, then the initial point minus 6. Now y minus 6 over the final x is 7. X minus 3. Now at that point, then we equate it to the gradient, because this is like the gradient, but the gradient of this line doesn't change. Now we equate it to the what? The gradient, which is 3 over 2. Now what do we do at that point? We cross multiply there. We cross multiply that. We find that at that point we'll have 3 into x minus 3. 3 into x minus 3 is equal to 2 into y minus 6. 2 into y minus 6. Now opening up this bracket, that is 3x minus 9 is equal to 2y minus 12. Then collecting the like, that's 2y minus 12. Collecting the like terms, I leave this one the other side. This one comes this way. I have 3x minus 9 plus 12 is equal to 2y. Is equal to 2y. Then minus 9 plus 12, that is plus 3. Now 3x plus 3 is equal to 2y. Then you divide by 2 both sides, because the equation of a set line is always y is equal to mx plus c. Equation of a set line. Now we want y alone at that point. Now we divide by that. I have y. Then that one is 3x over 2 plus 3 over 2 is equal to y. Now this is an equation. 3x over 2 plus 3 over 2 is equal to y. Now that can be y is equal to 3 over 2x plus 3 over 2. There is no difference. Now this is my equation of line AB. This is the equation of line AB. Now, from the equation of a straight line, the coefficients of x, which at this point we found to be 3 over 2, is always the gradient. And if you compare this value here with the gradient we found, with this gradient we found they are equal. Now that means the equation of that line is correct, having these coefficients to be what? To be the same as the gradient. Now the next thing after that, we find the equation of the perpendicular bisector of line AB. Now line AB, this is my line AB. Line AB is this. Now I have an equation of perpendicular bisector. Now perpendicular bisector can pass at any point. Now I can say the midpoint. I can just say it passes at the midpoint of line AB. Now I need to find this value, the midpoint of that line AB. The midpoint of line AB, midpoint of AB is given by x1 plus x2 over 2, comma, y1 plus y2 over 2. Now, what is x1 plus x2? x1 is this. This point is x1, that this point, because we are finding the midpoint of line AB. The midpoint of line AB. Now the midpoint is a point at the middle. Now I can take this x1 plus x2, that is 3 plus 7 over 2, comma, y1 plus y2. y1 is 12 plus 6. That is, y1 is 6 plus 12, 6 plus 12, that is y1 plus y2 over 2. And it is a point, now it is enclosed in bracket. That is 10 over 2, which is 5, comma, that is 18 over 2, which is 9. Now I find the midpoint of that line is 5, 9. Now this point here is 5, 9. I have that one there. Then perpendicular bisector to this line. Now there is a relationship there because we need to find its equation. We must have its gradient. We must have its gradient, and we must have one of the points, or which one of the points we found now, but we must have its gradient. But you know that to find this gradient, because we don't have another point, we cannot find gradient using the point, but we can find the gradient in relationship to perpendicular lines. We find that two perpendicular lines, if we multiply their gradient m1, then m2, so we give me -1. Because now, but we have the gradient of 1. This line is perpendicular to line AB, but the gradient of line AB was found to be 3 over 2. Now, I can say 3 over 2, because this is m1 is 3 over 2. Now 3 over 2 m2 is equal to -1. 3 over 2 m2 is equal to -1. Now, m2 can be is equal to -2 over 3. When you find this, you find it is -2 over 3. Because I divide this one by this one. Now we find it is -2 over 3. That is the gradient of this line here. Now I found its gradient and I have one of the points. I found its gradient and I have one of the points. You see, its gradient here is -2 over 3. I found its gradient. Then I have one of the point which is 5, 9 at that point. Now what do? I use the gradient and one of the point plus the arbitrary point that I'm going to choose, which is xy, to find the what? To find the equation. Now I have the gradient of that line. Gradient of that line is equal to -2 over 3. -2 over 3. Then I have one of the point which is 5, 9. I think so. Which is 5, 9. One of the points which is 5, 9. Now I have arbitrary point which is x, y. I mean x, y. I have an arbitrary point x, y. Now we need to find the equation. What do? I find this. I mean x minus y. I mean y minus 9 over x minus 5 is equal to -2 over 3. Is equal to -2 over 3. Then I cross multiply. Find that is 3 into y minus 9 is equal to -2 into x minus 5. What is that? 3y minus 27 is equal to -2x plus 10. -2x plus 10. What do? I take this one to the other side. This one goes to the other side. Now 3y is equal to
Because you know, why am I taking this to the other side? The equation must be y is equal to mx plus c. That is the equation we want. But if you look here, there are there's a constant at this point. Now we have to take this constant to the other side to find this equation in this form. Now taking that constant to the other side, I'll find that 3y is equal to negative 2x plus 10 plus 27. Now what is that? I find that 3y is equal to negative 2x plus 37 plus 37. Now I divide by 3 both sides, that's cancel. Y is equal to negative 2x over 3 plus 37 over 3. Now that is an equation. That is an equation of that line. If you look at this gradient, that value here, it's equal to the gradient we found. It's equal to the gradient we found. Now that means that is the equation. Then the next thing we want to find now, having found that equation, that was question B, which was 4 marks. Then question C, they are now asking, given that line AC, this is ABC. Now line AC is a line here. It's perpendicular to AB, meaning it makes right angle. That was a right angle triangle. It makes right angle at that point. Now line AC is perpendicular to AB, and the equation of line CB, or BC is y is equal to negative 5x plus 47. Y is equal to negative 5x plus 47. And now they want to find the coordinate over C. This coordinate of this point at C. We want to find that coordinate at C. Now we are told that this line AC is perpendicular to line AB. Now, what do we know about two perpendicular lines? I've said that when there are two perpendicular lines, the product of their gradients is -1. But we found that the gradient of this was 3/2. We found this gradient was 3/2. And there was another line which was also perpendicular to this, and we found its gradient to be what? -2/3. Meaning this line also, its gradient is -2/3 because it is also the same, it is also what? It's also perpendicular to line what? AB. The gradient is the same to the gradient of this perpendicular we found here. Now we found that gradient of line AC, I can put this way, all M, I can just say M AC is equal to -2/3. Because we calculated it somewhere here, there was a perpendicular line to line AC. And this is also perpendicular. Or you can say, if this line is perpendicular to AC, and this is also perpendicular to AC, then the line this and line this, they are what? Parallel. And two parallel lines, their gradients are the same. But we found the gradient of one to be -2/3. Now that means the gradient of line AC is also -2/3. Now having found that gradient, we have that gradient, and we have the point of origin, the initial point of this origin, which is point A. It starts from point A going to C. That means the initial of is this. I have the gradient. Then, having the gradient at one point, I can now get the equation. Having the gradient and a point, I can now get the equation. Let me find that equation. Now, equation of line AC is given by, we choose the arbitrary point xy. I have the point of origin at point A, which is 3,6. The point of origin is 3,6. Then I have another point xy on that line. Then I have this gradient to be -2/3. Now, what do I do here? Y minus 6. That is y minus 6 over x minus 3 is equal to -2/3. That is -2 into x minus 3, cross multiplying, -2 into x minus 3 is equal to 3 into y minus 6. Opening the bracket, I find that one is -2x
negative 2x plus 6. Negative 2x plus 6 is equal to 3y minus 18. 3y minus 18 is equal to 3y. That is 3y, not 3g. 3y minus 18. I want to remain with y only this side. This one comes the other side. Now I find that negative 2x plus 6 plus 18 is equal to 3y. 6 plus 18, that is 24. Now negative 3x plus negative 2x, negative 2x plus 24 is equal to 3y. Divide by 3, divide by 3. Now that is negative 2x plus 24 divided by 3 is 8. That is plus 8 is equal to y. This one was over 3. This one is negative, that one over 3. Because this one, all of this were divided. That's negative 2x over 3 plus 24 over 3 is equal to y. Now this remains that way. Now this is what? An equation of line AC. Having this equation, that is a question of line AC. Line AC. But we want to find the coordinates of point C. We want to find the coordinate of this point C. What do? You have an equation of this equation of line BC, and equation we now have an equation of line AC. We will now have an equation of line AC. Now this point here is a point of intersection of those two lines. That means the equation of line BC is equal to, at this point, the equation of line BC is equal to the equation of line AC. But we have the equation of line AC, we have the equation of line BC. Now I equate the two equations. The equation of line BC is given to be negative 5x plus 47. Now I can say negative 5x plus 47 is equal to negative 2 over 3x plus 8. What do I do? At that point? I find the value of x. Meaning I collect now the like terms. Let me now take this one to come this way, and this one here to go the other side route. Now what is that? I find that 47 minus 8 is equal to this one here, plus in the equal sign, it's a plus, then it comes to minus, is equal to negative 2 over 3x plus 5x. Now negative 2 over 3x plus 5x. This one here, 39, is equal to negative 2 over 3x plus 5x. That is 4 and 1 over 3. I think that is 4 and 1 over 3. 4 and 1 over 3x. That is 13. That is 13 over 3. Now 39 is equal to 13 over 3x. What do? I multiply by the reciprocal, which is 3 over 13. 3 over 13. This one here by 3 over 13. Then this goes with this. Now multiplying this by 3 over 13, I find this is 9. I think so. 39 multiplied by 3 over 13. That is 9. Now I find this is 9 is equal to x. Now the value of x there is 9. Now we want to find the value of y. To find the value of y, we take any of the equation, because we find that this equation is equal to this equation. Now even if we take this here, there's no problem. We take this here, there's no problem. Now we can say we can take this one here, because sometimes working with a fraction can bring a problem. Now let's take this one here. Having the value of x, now we want to find the value of y, because all these ones are equal to y. These ones here is equal to y, meaning this is equal to this and is equal to what? To y. Meaning any of this equation is equal to what? Y. Now we want to find that value of y. Now y, let me use this equation. Y is equal to negative 5 into 9, because the value of x is 9. Negative 5 into 9 plus 47. What is that? Negative, that one? That becomes negative 45. Y is equal to negative 45
plus 47. Then y is equal to 2. Now, having the value of x and y, and you know a point, C is a point. C is a point, a coordinate point. That means it must be in form of x, comma, y. Then what is the value of x? 9, 2. And that is the coordinate of that point. Now the coordinate of that point is C is 9, 2. And that is the end of that. And I believe you enjoyed it. That was the question of 2018 KCSE. I think you enjoyed the lesson. Now please follow it. Follow it very keenly. It will help you from this point, because we found part A ended at this point, the equation of AB. That was the end of part A of the question. Then part B was to find the equation of bisector of AB, that was which we found at this point. Then part C was to find the coordinate of C. What was that? Meaning part C starts at this, part B starts at this, then part A was starting at this point. And that is the end of our discussion today. Thank you. You can now subscribe to the channel and watch more videos as they pop in.